Hello and welcome to the Slingshot channel. Today we want to build an instant Legolas for this English longbow, 55 pound model. But this time we're not going to use plywood because it is debatable if something like plywood has been available in medieval times. So we want to use ordinary wood, but of course I'm not a carpenter, so therefore I'm still going to use modern machinery, since it is absolutely certain that in medieval times people knew how to work on plain pieces of wood. They had everything. They had like sawmills, and they had of course lots of hand tools and hand saws and so on. So I'm not going to do that because it is absolutely clear that that would have been possible for a medieval craftsman. I just want to show you that it is possible to make the device from ordinary wood. And of course I'm also going to show you a few techniques how you can strengthen that wood so that it doesn't matter that it's not plywood. What I have is just these plain beech planks. I have them in 3 different thicknesses, even though only the middle layer is really important that it's straight. The other layers don't have to be perfectly sized. Just the middle layer has to be a little thicker than the arrow that we're going to use. So I have 12mm, I have 10mm planks, and I have 4mm planks. All not plywood, just regular nice beech. I don't think in medieval times like modern screws have been very popular. Therefore all we're going to use is glue. This is modern glue, but of course in medieval times they had perfectly good glue. Just took longer to set, and therefore I'm still gonna go back to these here, but it is certain that they would have been able to glue 2 pieces of wood together. And since we don't have any screws, I'm using these rusty nails here as a replacement. I'm going to show you how to use them to strengthen the non-plywood boards so that they will be good to endure the stress during shooting. Well, coil springs and steel springs, I think in general, have not been very common in medieval times. So I'm using an old arrow shaft that is sawed off at one end. And as you see, it's simply clamped in between these 2 nails here. And it has plenty of spring power, so you can easily stack like maybe 4 arrows inside here. And then I think it will function just fine. So these are our medieval blueprints, as always sketched directly to the wood. As you see, the lower part is a little bit thicker because this wood is not as solid as plywood. This is the contact part for the bow stave. So this will be mounted to the bow stave here, and it will glide to the left side. And I'll explain to you later on why that is. Also, what I have to say is that here you can see there is no spring, because I don't really see a way of making a spring from like wood or so on that would fit in here. But the beauty of the one-piece trigger sear design is that no spring is needed. You can simply, when you push the sliding Legolini in, at the end you simply like flick your thumb up and then it automatically locks. This lock does not need a spring. You can just simply compensate by practicing this a little bit. And as you can also see, there is a little bit of extra space needed here. That is for clamping in the wooden shaft, the wooden spring that presses down on the magazine. And as you can see here, this is how the arrows will stack up in the magazine. They can't slide forward because of the vanes. So this is the outer layer in 4mm, and as I said, it could be thicker, it could be anything. It could be 6mm or 8mm, as thick as you want. Just it gets more bulky and more heavy if you don't use thin wood. So this is basically the first part. It's actually the top layer. And as you can see, it has enough room for the spring here. This is where the arrow shaft is, where the bow shaft is going to be at. And here we're going to put in the arrows. And yes, the handle, I don't really have enough room for the lower part, but that is not a problem because this is the part that is critical here. The rest we can simply attach it later on, since it's only for comfort. The power vector goes along the line of the string here. We're going to use this part actually as some kind of a template for all the other parts, because they're more or less following the same line, just a little bit different. The next board we're going to be working on is this one. It's actually the second layer out of a total of 5. And this one actually, the thickness of this one is 12 millimeters, but it could be thicker. It is defined by it must be at least as thick as the veins protruding from the arrow shaft, like this. So this is kind of perfect. But it could be a little wider, that wouldn't matter. It would just make it more bulky and add a little bit of weight. These are the two layers, the two first layers above each other. And as you can see, there's 4 arrows inside, and the spring arrow is pressing down on them. Of course, right now it's not on intention. And you can also see that the veins actually are nicely centered here. So, see, there's room for the veins here, like so. And this is where the trigger will later lock in. And as you see, the inner layer will have to be, the slot will have to go all the way through, so that the veins can actually easily slide through all the way until the shot falls. And now of course we need an inner layer that keeps it all together. And these parts actually we have to saw them out twice. Now we will have to make the inner layer, which is most important. And actually we can make this in a few pieces, so you wouldn't need a whole board for it. This is the part where the trigger sear mechanism will be inserted. And this will be the arrow guide. And then we have a front part, which is here. And now we glue the pieces together. First the 2 outer layers respectively, and then we will have to focus on the internal layer. Next we take the leftover piece from the inner board and we saw out the trigger sear part. Note that we turned it around like 45 degrees or something, because now the most important part is this one here. This is where a lot of pressure will be at once the weapon is fully cocked, and therefore we don't want the fiber direction to go against it, so it lasts longer. Now we sawed out the part, and we also already drilled a hole for the axis, but now comes an important part, and that is you have to drill a hole into this part here, and then take a nail and glue it in so that it further stabilizes the trigger sear part. Like so, because now it won't break off that easily, and that is important. So this is how it's supposed to look like. As you see, we drilled a hole in for the axis, our rusty nail. And also note that we really kind of blunted the tip here so that it feels absolutely smooth and not edgy, because otherwise the string will be damaged. You can see the filed off end of the nail here that gives it stability, but before we put it into the weapon we need to make sure that it will be holding, and therefore we clamp it into the vise. So now it is firmly into the vise here around its joint, and now we take some string, can be any string like paracord and so on. We put it over the notch here, and then we grab it and we pull hard, really hard as you can, with both hands. And you can even put like a knee against the table and pull hard. And as you see, that was too weak. So we gotta do again and maybe use a different part of the wood. One more attempt. As you see, this time I took a different wood grain. I now took the wood grain downwards so that actually the part that would have to tear has the longest contact. And also I put 2 nails in just almost straight. Let's see how this one fares. This is one of the great advantages of the plywood, because plywood never causes these problems since, you know, they are rotated in layers and therefore you have no fiber direction. This one is of course more critical. Okay, same procedure. Put in our string. Okay, apply some pressure. It holds. Next we drill the corresponding hole into the main part, into the inner part, and we put it on, and then we are sketching the outlines to it. Pull the trigger and sketch the outlines again. Okay, now pull the trigger, like so. As you see now, the string would be free. And now we exactly know how to saw out the parts, and in the end we will have 2 parts. We will have this part and we have the 2 other parts. And once you glued all the parts together again, this is what you get. You get this manual, no spring driven trigger sear mechanism, and as you see, since this is in line with the axis, you don't need a spring for it to hold as much weight as it can hold from its pure stability. And then when you want to shoot, you simply press this and the shot falls. So this is how the situation looks like now that we have about half of it finished. As you see, we have our trigger sear thing here, and here we have the arrow magazine. Oops. And in the end they will be stacked in like so, and the spring will press down on them so they will land here, and when you pull the trigger, the lowest one will actually shoot out to the front like so and be on its way. Very simple. It is important that this edge is precise, because what should not happen is that even if they cant upwards, that will happen when the string moves under them, they should not be able to get into this little canal here. So this needs to be tight enough that the arrow doesn't fall out. And as you see also, there is like a groove in the middle so that the arrow can also not move out to the side here. Very important. So now we put in our magazine spring, which is really only the wooden arrow. And as you see, it's simply squeezed in between these 2 nails. And actually I put a 3rd nail through it here, a very thin one, to make sure that it's not moving back and forth, so that it's firmly in place. So this is how it works. It clamps down on the arrow, and as you see, the arrow will not move much, so it won't fall out in the final contraption. And as you see, you can also put more arrows in. Very simple, elegant solution, I think. So we glued the other parts, the other half together, and now we can put them over each other and then glue the whole thing in place. Make sure it's precise enough so that the slot is continuous and the string has a free passage. So now we put the whole thing together. As you see, it's completely functional together with the trigger, everything. And we can load in an arrow, like so. It's securely clamped down by the wooden spring. And then if the shot falls, so this is here, like, put this in here, like so. So this will hold, and as soon as the shot falls, the string will be able to accelerate the arrow down the barrel until it shoots out, like so. Of course, there is a lot of rounding ahead of us, but before we do that, I first like to make sure that these layers won't be falling apart. And for doing that, we will be using some wooden sticks, like these are like shashlik pins, but you can use anything else, and drill some holes through and then put them in. But we will do this at a slight angle, The angle will actually alternate so that the layers cannot really become apart once we drilled and glued in these pieces of wood. In order to complete the grip, we'll simply use an ordinary piece of wood, doesn't matter what type, and we will use as a dowel the rest of the magazine spring arrow. That's going to fit exactly inside here, like so. So this is how it's now looking like, and all you have to do is now plenty of rounding. So now we rounded it a little bit, and as you see, now the rear handle is perfectly fitted and everything is functional. What we now need is some rails so that later on it will run just fine along the sled. So we need to saw out straight pieces of wood, of thin wood. So now the rails are glued on, and this thing is basically finished. Of course, it still needs to be, improved in terms of look. But other than that, it is now a functional sliding instant Legolas. What we now need to build is the other side of the rail system that then will be attached to the bow itself. To really make the other side of the rail system, what we do is we use the leftover parts from our 12mm board. Could be any other thickness too, and make a U profile out of it by simply gluing it in, and then as before using nails or wooden rods to keep it in place so that it's not just all sitting on the glue. Of course, this would be much nicer if I could use screws, which I can't. Anyway, so this is the glued together box, and it slides with very little tolerances, but a little bit too tight, but we'll take care of that later. First of all, now we have to make sure that it's not going to fall apart, so we have to stabilize it. So this is the final U profile. As you see, it is doweled and glued, and therefore it is really, really, really solid. I don't think that it would be much more solid if I would have been using screws as per usual. And also I think it looks kind of cool. And this is the way how it glides. As you see, there is not much play, but it is smooth enough. Very nice. So now that the device itself is finished, we now need to make the attachment to the longbow, and we will be using a plank made from, I think it is pine. It's been lying outside, so yeah, it's a little bit bent, but that doesn't matter. So it's a board that would not have been a problem to find in medieval times. So this is basically the holder. As you see, there is a cutout for the bow staff and also a cutout for the sled. And this is how it's going to be put together. As you see, it will be holding the U profile, and the instant Legolas will glide just above just beneath the bow staff. So this is basically the handle, and it will later on be tied to the bow. And as you see, it's now glued in place. But of course, I need to stabilize it with a nail, otherwise it will break off real easy. So here you can see how this is going to be attached to it. As you see, the handle is nice and centered, and it will be of course tied in place with string later on, and there will be another piece on top. And this will be the holder for the sled here, like here. Now we glued this on, and as you see, also filed down a little bit of here so that it's comfortable to hold. And Now of course we have to peg it because otherwise it would not hold. Nice. So this is the upper part of the holder. And by the way, I wanted to show you that we're kind of making our own plywood, because to reach the necessary thickness, I'm actually using parts of the leftover 4mm beech wood and a little bit of the pine board to form the thickness that I wanted, but at the same time it will stabilize it. Now I will be pegging this one too, so that the whole thing basically forms one solid block of wood. So this is now the finished holder. Actually, I have to say it was more work than the entire sliding Legolas part, because it needs to be very sturdy. But also because I haven't been using any screws and so on, and no plywood. In the end, I think it is still really good. I think it's the nicest one I've made so far, because it feels like I've done a proper job. Only thing that is left to do is apply a little bit of linseed oil so that it will not bend and warp immediately when it gets a little bit wet. Now what is still missing is like the front lever to hold it back, like the medieval let-off. And again, we had to make our own plywood. Actually, you could see it nicely here. You can see that the grain is different direction so that it will hold. So I again glued together some pieces of the leftover wood. And since we don't have any screws, but this still needs to be possible to take it apart, since otherwise you can't install the whole thing. What I've been doing is I've been using nails, even gave them some kind of medieval look, so that they can just be used as pegs and you can remove them at any time. Okay, and here it is, fully attached as you see, with hemp rope, as befitting for the era. And as I said, it has been made with no screws, no plywood, no springs, at least no steel springs, just from material that was available in medieval times. The only thing that I did is I cheated by not using hand saws, but normal electric saws. And also I've been using modern glue, but they had plenty of glue in medieval times, mostly made from like animal skin and bones, and also from cheese, as funny as it sounds. Anyway, but now we have to test it, and I'm not sure if it's gonna hold. I have like mixed emotions. This is a powerful bow, but there's only one way to find out. So we push it to the front, and now you have to, because there is no spring, flip your thumb up and then hope that the thing is holding. So far it does. Okay, fully drawn. Let's see if I can trust my medieval let-off. I can, it holds. And the trigger holds. That's amazing. Fire! Whoa! It works! Do one more. Into the black. It works. 4 shots. Let's see if we can do all 4. Just one. And then it has passed the test, I guess. Wow! Okay, let's reload the weapon. And you do this shotgun style. So, clack. I think the spring is even more powerful than the spring in my more modern types. It works beautifully. Shot. And all of 4 of them are in. Great. Okay, let's do 4 more shots at the target. And of course I still have no aiming device, but it is great fun. And okay, a little bit too high. A little bit too low. Just right. Not bad. I think people underestimate how powerful hardwood is. See, this wooden trigger holds, and it does this without the support of any spring. So you lock it, and of course it would also automatically jump down. You just have to flip it up. It's so easy. Now, is there like a major difference between this one and the ones that I make from plywood with screws? No, once it's completed, it absolutely feels the same. It is a little more bulky, but that is mostly because I'm using the bigger bolts here, not the very thin bolts that I've been using for other devices made for the Cobra R9 crossbow. They are heavier, and so they're more matching to the more powerful bow that I'm using here. Other than that, it is just the instant Legolas feeling, with the difference that you just have to flip up the thumb, but it's really not a problem at all. Solidity, stability is great, and I already fully trust the weapon. It just shoots and shoots and shoots, just like it should. Not a bad group for an untrained archer with no practice in longbow shooting. So after probably a few dozen shots, it feels like this thing is indestructible. It is a little more bulky here, that's because of the more awkward spring. But I think actually from functionality side, this spring even works better than a regular arm with a coil spring at the other side. So I think overall it's just a perfect thing, and I even think the looks are quite nice. I mean, isn't that like a matching look for the bow itself? I think so. And I think it's my favorite instant Legolas so far. Also, I like that it can be taken apart so quickly, because all you gotta do is remove these rods here. Then you can remove the front medieval let-off piece here. Then you can slide this out, and then all you have to do is remove the string, and then the thing comes apart into two parts, into two pieces, and you can transport it just like normal. So it is really not even clumsy to transport. In any case, I am super convinced that someone who can make a bow like this, and even more powerful than this one, is certainly able to make a device like this, now that I've proved that the materials would be absolutely sufficient. So I enjoy this thing, and I hope that Todd from Todd's workshop is going to teach us how to actually do something like this, but with medieval tools and medieval skill sets. That's going to be really interesting to see what he's going to come up with. I can't wait to see the features of the thing that he builds. In any case, that's it for today. Thanks, Em. This is just too much fun. Bye. Bye. As always, one for you, one for you.